In today's video, I'll be explaining why someone supplementing with NAC might not feel the benefits and sometimes feel even worse. The focus will be on various epigenetic factors that can influence the enzyme's activity and how cofactors could affect the interplays within the pathways. So let's break down into two scenarios. Scenario 1. Someone might have a GCLC SNPs. Either he's born with it or got dirty due to poor lifestyle and other epigenetic factors from the environment. So what are SNPs? SNPs are singular nucleotide polymorphism. These are tiny variations in a gene. So GCLC SNPs are variations in a gene that codes the GCLC enzyme. So these variations can lead to a less efficient, slower, or less stable GCLC enzyme. To understand this, we first need to understand how glutathione is synthesized. The glutathione synthesis via transsulfuration pathway looks like this. When you supplement with NAC, the NAC is converted to cystine. Then together with the cofactors like your ATP, your glutamate, together with your GCLC enzymes, they will transform into or converted into gamma-glutamyl-cysteine. Then step 2, gamma-glutamyl-cysteine will be converted to glutathione via the GSS enzyme, which stands for glutathione synthase, together with cofactors such as your ATP, magnesium, and glycine. The problem with taking NAC in this case is because we can use this bottleneck analogy. Think of the glutathione production line as a two-step factory. Step 1 GCLC is a narrow and slow bottleneck, as you can see over here. Then step 2, the GSS is a wide, fast highway. Normally, NAC provides more cystine, the raw material to push through the bottleneck and make more glutathione. With a GCLC SNP, together with these inhibitors, this could slow down the enzyme activities even further, causing this bottleneck even tighter and slower. Therefore, dumping a large amount of cystine before this bottleneck doesn't help. The raw material will just pile up and can't process efficiently into the next stage. Eventually, it will go sideways, either go to the cystine pathway or heading to the sulfite metabolism shown here. And I will get that in a while. There's also oxidative stress which you need to consider, because if the GCLC enzyme is inefficient, the cell may already be under significant oxidative stress. Then there's scenario number 2, which might be someone having chronic infections or mold exposure. This situation is different and involves the complex interactions between the host, the person, and the pathogen, the mold and fungi. Pathogenic mold produces toxins called mycotoxins, and these mycotoxins are a major source of oxidative stress for the human body. The body's immune system also kicks into gear, sending out oxidative bursts trying to zap all those mold spores, and this might result in a high energy warfare situation. So the problem with someone taking NAC in this case, the NAC might be fueling the mold, not just yourself. Both human cells and the mold uses glutathione and its precursor cystine to protect themselves from oxidative stress. So when you take a lot of NAC, you are not only supplying your own cells with cystine, but you also can potentially supplying the invading mold colonies. Then mold can use this to strengthen its own antioxidants defenses, making it more resilient to your body's immune attack. It's like giving your enemy body armor in the middle of the battle. Do you see where it goes? NAC also acts as a biofilm disruptor, because many molds and chronic infections create protective structures called biofilms. These are slimy communal fortresses that make the infections extremely hard to eradicate. And NAC is well known for its mucolytic properties. Okay, while this is good for lung congestions, it can also help to break down these biofilms. Releasing a large amount of mold spores and mycotoxins from a biofilm all at one go can be very severe and inflammatory, causing these hexamer effects, which can make the person feel even worse. NAC acts as a very powerful antioxidant. In the complex redox signaling environment of a chronic infections, simply dumping a global antioxidant can disrupt the delicate signaling that the immune system uses to coordinate attack. It can inadvertently put out the fire too early that the immune system is trying to kill those pathogens. It's like your body's immune system is trying to kill some invaders, some pathogens. But in the process, they receive a lot of all these fire extinguishers, which might kill off the fire too early. So right now, let's do a very quick summary. An inefficient GCLC enzyme creates a bottleneck in the glutathione productions. Then NAC provides these raw materials that can't get through the bottleneck, potentially causing backfire and feedback inhibitions. We will discuss some of the protocols later on. Then there's also someone having these chronic mold infections. A chronic biotoxin illness can cause high oxidative stress and immune dysregulations. Then why NAC might fail in this case? Because the NAC might be fueling the mold's own defense and disrupt biofilms too aggressively, potentially worsening someone's symptoms. Okay, so what happens if you take too much NAC? Let's view the transsulfuration pathway again to better illustrate this. So when you flood NAC into the system, it can cause cystine here to overspill. This can mess up with the usual control metabolic pathways and shunt more cystines toward these two pathways shown here. To the right, it can convert to cystine, which highly dependable on the cellular environment. Then to the left, it generates sulfites and taurine for energy and excretion. It's important to understand that NAC itself doesn't directly convert to these molecules. Instead, it provides cystine, which then enters into different metabolic pathways that can have these different outcomes under specific conditions. When cystine is converted to cystine, this pathway is straightforward and it relates to the redox state of the cell, the reduction and oxidations. NAC is first deacylated in the body, primarily in the liver and kidney, to form L-cysteine. And this is the primary active form that the cells uses. Cystine has a thiol group that is highly sensitive to oxidations. In an oxidizing environment, two molecules of cystine can be oxidized to form a disulfide bond between them, and this linked molecule becomes cystine. We now know that supplementing a lot of NAC can potentially flood the cell with a lot of cystine. And if the cellular environment is already pro-oxidants, the conversion from cystine to cystine can happen more readily. At the same time, it also influences other biochemical pathways that can lead to the production of reactive nitrogen species like peroxynitrate. Cystine from NAC can also be broken down by several enzymes as shown here on the left. Then one major pathway involves the enzyme CDO, which converts cystines to cystine sulfinate, then eventually leading to beneficial compounds like taurine and sulfate via these diverging pathways. Before sulfates is being converted, sulfites here are very reactive and potentially toxic molecules, and they must be rapidly neutralized. And this is done by the enzyme sulfite oxidase, which requires the essential trace minerals like molybdenum as a cofactor, which converts sulfites into harmless, usable sulfates. This is the most crucial and rate-limiting steps to prevent sulfite buildup. The sulfates produced here are then used in the sulfation pathway under phase 2 detoxification pathway, primarily in the liver. This process attaches a sulfate group to various toxins, hormones like estrogens, and drugs to make them more water soluble so that it can be excreted in urine or bowel. While sulfate conversion rate can be reduced, causing sulfites to build up along here. Sulfites can accumulate if the rate of sulfite production exceeds the rate of sulfite clearance by sulfate oxidase. Here are some specific reasons why this can occur. It could be due to genetic deficiency in the sulfite oxidase. This is the most direct cause. Mutations in the SUOX genes can lead to a less active or less efficient SUOX enzyme. And this is also one of the key reasons why someone having severe intolerance to sulfur-containing foods and supplements. It can also be due to molybdenum deficiency. Molybdenum is an essential cofactor for the SUOX enzyme. Without adequate molybdenum, the SUOX cannot function properly. Even the enzyme itself doesn't have any mutations. We also know that modern soils can be also depleted in molybdenum, leading to low levels in our diet. And our gut issues can also impair its absorption. Then if you overwhelm the pathway with high NAC supplements doses, even with a fully functional source of enzymes and sufficient molybdenum, there is also a limit to how many sulfite it can process per unit of time. Taking very high doses of NAC can simply exceed the capacity, leading to a temporary buildup. If the liver is already overburdened with toxins from moles and chemicals, the entire detoxification pathway, including the sulfation pathway, can become congested. When sulfites accumulate, they can cause a range of symptoms, which often resembling an allergic reaction or histamine intolerance. Because sulfites can also trigger the release of histamine, then common symptoms like wheezing, tightness of chest, skin flushing, hives, and itching. They can also cause some neurological and digestive issues like your brain fog, your headaches, and even abdominal pain. So what to do if you suspect yourself having a sulfite buildup from NAC or high sulfur food? Instead of pushing the precursor NAC through a broken system, the strategy is to support the pathway, and the first and most obvious step is to stop your NAC supplements. Support sulfite detoxifications, and the goal is to enhance the function of sulfite oxidase, increase dietary molybdenum through or maybe through supplementations. This is also the most direct interventions. And the most common supplemental form will be either molybdenum glycinate or molybdenum citrate. Do note that this should be done under the guidance of a healthcare professional. If you need glutathione support but react to NAC, you might want to consider getting direct glutathione support, either using liposomal glutathione or sublingual glutathione that can bypass the broken enzymatic step entirely to provide the finished products to your cells. You can also use SAM to support the glutathione production through a different pathway. Because SAM acts as an allosteric regulator, as mentioned in my past video, so higher SAM can actually speed up CBS enzyme activity. You can also support the GCLC enzyme by providing nutrients like alpha lipoic acids and milk teaser. This can help to support the expression and function of the enzymes. You also can get yourself tested through functional lab testings, or maybe for example genetic panels, to look for SUOX and other sulfur metabolism SNPs like the CBS. But remember, analyzing the result is another story. You need an integrative mindset to view the pathways and not simply treating a specific gene or enzymes. You can also use urinary sulfites or sulfate level, which can be used to assess the efficiency of your sulfur metabolism. You can also reduce toxin exposures and overall oxidative stress burden, which can reduce the burden of the liver. The priority here is to address the underlying issues. It could be coming from the food you eat, the water you drink, the air you breathe, and the environment you're exposed to. And if you're someone exposed to mold environment, the absolute first step is to remove yourself out of the moldy environment and relocate as soon as possible. Then before entering into any new space, engage a certified mold inspector or indoor environmental professional for clearance. What we want here is to avoid continual exposure that can make all the protocols above useless. Under medical supervision, antifungal medications or herbs can be used directly to target the mold. Yet at the same time, prescribed binders like cholestyramine or over-the-counter activated charcoal or bentonite clay can also be used to prevent any reabsorptions and facilitate excretions in feces. Then with careful antioxidant support, some practitioners will use glutathione itself, often in conjunction with the binders and antifungal treatment, but the timing and doses are very critical. The strategy is to bolster the patient's defense without significantly feeding the pathogen. There's one key important thing to take note. For steps 6 to 8, you have to work closely with a certified mold trained practitioner when using all these protocols, preferably someone who has been trained by Dr. Richie Shoemaker or Dr. Neil Nathan. These are the two doctors whom I know which are very well known in the MO space. In essence, supplementing with NAC may cause potential buildup of sulfites from various enzyme inhibitors or SNPs. Always look at a wider perspective and locate the source of congestions. And remember, removing is always easier than adding. Thanks for watching. If you have not watched the video on methylation cycle, do click here.